So, let's get a couple of things taken care of here. So on your note sheets, Lauren, would you check to make sure I can that on? I know I switched to video. I think I'm trying to press the button.
Yes, good.
Okay, so here is the plan. On page 17, at the top, we did not do problem D. So let's do that because that'll get us back in the groove of what we were doing yesterday. So we're going to write an equation. We do not know what this picture looks like, but we do know that it has zeros at -1, at 2, and at 4. And it contains the point 1, 10. So I don't know what it looks like. I'm going to go ahead and just dash in something. It could look like that, right? That would be something it could look like. But my job is not to graph it. My job is to write its equation. Okay? Now, start with the parentheses. Remember this from yesterday? Why did I put 3 parentheses? Because I have 3 zeros, 3 x-intercepts, 3 dots on the x-axis. However many dots on the x-axis, that's how many parentheses you're going to have. This one doesn't count. We use them for something else. We look at the dots on the x-axis. Now what goes in the parentheses? Look at what the dots are. So the x plus 1. There you go. Now you are done, except this number right here. We don't know what it is. Sometimes I use A, sometimes I use N. Does it make any difference? No, we're finding this mystery number. In order to find the mystery number, we use this extra point, which is an extra x and y. So I'll put 10 in for y and 1 in for x. So I've got 2, -1, and -3. So 10 equals 6a. So a equals 10/6, which reduces to 5/3. And our answer is y equals 5/3, and then all that. X plus 1, x minus 2, x minus 4. You do not have to multiply that out. That's how you leave it. Now, take a look at the next problem. Factor and sketch. So now we have to factor this guy. Now he has a bunch of terms. How do we factor when we have that many terms? Julian?
Separate them.
Anybody know we call that officially factoring by grouping. So he said separate and group them together. So let's look right here. What can we take out of those 2 terms? X squared. So we'll take out x squared. Now looking at just these 2 terms, what will I have left if I take out an x squared? X minus 4. I'm looking only at these 2. All right, so now I move down here. Oh my. The only thing I could take out of those two would be a -1. What would that leave me with if I took out a -1? A positive x and a -4. Now your heart is filled with great joy because your factors match. If they don't match, you've done something wrong. Write down the matching factor. I'm going to stop right here. Look at what I wrote down. Did I put a squared on it? Did I put 2 of them? I wrote down the matching factor. And then I'm going to write down everything else. So that would be the x squared and the -1. Now what can you tell me about x squared and -1? X squared minus 1. What can you tell me about that? X plus 1, x minus 1. Very good, thank you. So now the problem is completely factored. And now it's time to sketch it. Okay, we did this yesterday. How do we even start sketching this guy? We plot points. And the points we plot are on the x-axis. So where will I put my points on the x-axis? There's one at 4. There's one at -1. And there's one at +1. Right? What's the degree of this polynomial? Third degree. Okay, now wait a minute. Third degree, what did we learn yesterday? If you're third degree, you're starting down and ending up. So I'm going to start down here. Now every time I hit a dot, I have to make a choice. Do I just zip right through? Do I bounce off? Do I squiggle through? Remember, those are my 3 options. I can just go straight through, I can squiggle through, or I can bounce off. What's happening, take a look at these factors, what's going to happen in this problem? They're all just going straight through. And we know they're all just going straight through because why?
There's no squares.
There's no squares, there's no powers. So I'm just going to go straight through, connect my dots, and there's my picture. Take.
Why do you not put like x minus 4 squared? Because there's like 2.
Okay, but it's a common factor. It's like when you have, if you had 4x plus 7x, then I said take out the x. They both have an x, right? There's 2 x's there, but when you factor it out, you only write it one time. So we have, this is our common factor. This is like our x. We got 1 here and 1 here. When I factor it out, I only write it once. Okay, so just know, only write it once. All right, everybody okay with that? Now, did we do that yesterday? No. We did this part yesterday.
No, we didn't do the factoring.
What's the part we didn't do yesterday? The factoring part. Yesterday, all of our pictures were already factored. All right. Now we're going to do 2 more, and then we're going to look at homework questions, okay? So let's do the next one. Okay, help me out here. What's your thought when you see this problem, Ashley? Do you talk this much always, or is it just been a fun?
Yeah, I just talk a lot.
Oh.
All right, who's got a plan? Mr. Devine. What's your thought? What are the first two? What can we take out of the first two? Okay. And what will we be left with? Uh-huh. Good. Now go ahead and do the last two for me. Yep. And when you take out the negative 4, you will again be left with x plus 3. So there's our common factor. See it, everybody? So we write it down. And then we write everything else that's left. Now what about x squared minus 4? X plus 2, x minus 2. And there's our problem. Beautiful. Anybody have an issue getting it here? Because if you can't get it factored, you can't sketch it. Okay, but now it's factored, so now we can sketch. So Moses, what do I do?
You gotta do, so it's a third degree, so it's down and up, it's minus 3, plus 2, it's minus 2. So,
I think somewhere in there was probably the right answer. Let's kind of make it a little bit more clear. So the first thing I'm going to do is put dots on the x-axis.
yeah, it's minus 3, so x minus 3 right there.
Yep.
So it's minus 2. So, yeah, right there.
There we go. Then I heard him say it's x to the third, so it's down and up. And I think what he meant in Moses' talk was that we start down and end up. And he's exactly right. So, before I start though, am I going to have any bounces or squiggles? Nope, just going to zip straight through the whole way, so here we go. Now,
How do you know if you have the bounces?
somebody tell him. Now, your picture may go higher than mine or lower than mine, and that's okay. Not worried about that right now. Just worried about getting this shape and crossing at these places. All right, one more, then we'll look at our homework. All right. Zach Bond, got any thoughts on this one?
Yeah, factor 2x squared, take that out in the first part.
All right, so first two terms, take out a 2x squared, beautiful.
And then I took out negative 8 on the x.
Okay, wait, one at a time. What did you get when you took out 2x squared?
Oh, I got x minus 1.
Good. And then you took out a negative 8?
Yeah, and
That
I
is
got
a great choice.
x minus 7 here.
Yeah, perfect, beautiful.
And then I got negative 2x squared minus 8, and then x 2 minus 1. And I don't know what to do. I don't know that. Well, I think I do. It's like 2x minus 4, something like that.
Well, let's look at this carefully. Zach says that he got this far, and it's beautiful. To this point, it's absolutely beautiful. Connie, got an idea?
Can you divide by 2 at the beginning?
You can't divide by 2 at the beginning because this is a y, and then you would have 1/2 y. But what you can do is factor out a 2 from the beginning. And Connor, here's the deal. We didn't, Zach didn't, and that's perfectly okay. But now, see this parentheses, he's going to have to take the 2 out now. So we're going to take the 2 out now. And I'm going to go ahead and write it in the front because I don't like to have a number in the middle of the problem. What will I have left if I take a 2 out of this one? X squared minus 4. And what about x squared minus 4? Okay, I'm starting to think Eric is the only one that knows how to factor the difference of squares. Does everybody see x squared minus 4 is x plus 2, x minus 2? So here you go. Now, we're used to numbers being out here. These are the numbers that tell us how stretched or upside down or whatever the curve is. That number is not an x. It has nothing to do with the dots you put on the number line. There are 3 x's in the problem, so there are going to be 3 dots. Do not let that 2 interfere. You're going to have a dot at 1, at 2, and at -2. That number right there controls things about the graph. If it were negative, we would know to start up and then down. It's positive, so I'm still going to start down here and end up here. I don't plot that number. I only plot the x's. Okay? Now, was there a homework question? Did anyone have a homework question that you would like to?
She went over it already.
Yeah, it's just the factoring. Because there's
Is
not
the factoring?
Okay, good.
So you're good on the factoring now? Everybody's good? So if you had an issue with the factoring, you might want to take a second look at those problems.
Yeah.
And see if you can get those sorted out. Okay. Now let's look at number 4. This is where real math comes in. Now we're going to look at something that's not, you may not have done before. This may be the first new thing we do. Now take a look at that. The directions say factor and sketch. Now wait a second. Factor and sketch. What's an issue? We did a whole bunch of those. What's the issue here? It does not factor by grouping. Oh my gosh. What do you do when you have to factor something that you can't group? Well, this is exciting. Your job is to find factors. Now, factors are numbers that you can divide in and get a no remainder, right? So if I say 5 is a factor of 10, that means 5 divides into 10 evenly. 7 is not a factor of 10 because it doesn't divide in evenly, right? So your job is to find numbers that you can divide into this and get no remainder. Now you're thinking, divide into that. Last year, did you do something called synthetic division? And you loved it. Good. We're going to do synthetic division. We are going to simply guess numbers, and we're going to keep dividing until what happens? We get a remainder of 0. Now, if I were you, I would be thinking, a little bit panic side here, I'd be thinking, wait a minute, Ms. Fuller, wait a minute, guess numbers. That could take a long time because there are a lot of numbers to guess. We have a way of narrowing down your guesses. The numbers I want you to guess are called the possible rational roots. You will see on your paper, I wrote PRR. Those are the possible rational roots. They're the possibilities. So instead of guessing from every number in the whole wide world, we're going to guess just a little pool of numbers. And the pool is found by taking all the factors of this number and dividing them by all the factors of this number. So wait a second. What are the factors of 6? Plus or minus 6, 3, 2, and 1? In any order, it doesn't matter. For positive and negative, all of those. Divided by the factors of, oh, what's this? That's a 1, right? Understood 1? And the factors of 1 are just 1. So I'm not even going to worry about those. So you're going to do some synthetic division, and we're going to practice that again in case you've forgotten. You're going to do some synthetic division, but the only numbers you're going to try are numbers in this list. So for example, you'll try 1. 1's in the list, right? I'll try 1. So when I do synthetic division, I'm going to put a number 1 out here in the box. And then I'm going to write down all the coefficients of my problem. So 1, 2, -5, -6. You okay with that? And then I'm going to leave a space here because I'm going to be putting some numbers in there. And I drop this one straight down. Is this looking familiar? Now, do you remember what you do next? We're ready to start now. Do you remember what you do? 1 times 1 and write the answer here. And you add those, so we get 3. Then 1 times 3 and write the answer here. And we add those and get -2. 1 times -2 and add those. Shoot. Drat. I did not find a factor. Do you remember that this number right here is the remainder? And if I want a factor, what do I want my remainder to be? 0. So guess what? We're going to pick another number. Let's try -1. Start over again. Here we go. We're going to get lots of synthetic division practice. Notice I put -1 out here this time. 1 comes down. Here we go. Add.
No way.
That means that a dot, I'll space here. That means that a dot is going to go on my graph at -1. Because when I did the division, I ended up with a remainder of 0. Now, does anybody remember what the rest of these numbers mean? The last one is the remainder, but do you remember what all this stands for? X squared plus x minus 6. Now, why is it x squared? Because the original was x cubed, and I divided something out so it went down 1 to x squared. Now, what do you think about that? Can you factor that? How does that factor?
-2 plus 3.
Which tells me, Moses, that the other 2 dots go on here at -3 and +2. Right, Moses? And I'm going to stretch it. Oh my God, that's a big deal. That is a big deal, kids. That's real math.
So, for this infinite division, it will always work if it like matches underneath. Like, well, like, since the 1 has a +1, a -1, and how the 6 has a 1, 2, then it has to be that one. Like, you know, like if they have like more numbers underneath.
Yeah. If it works, it is right there.
Yeah.
Yeah, that's what has to happen. All right, are you ready to try another one? Here we go. Let's get this one. I'm done with this one. We'll stop. Okay, here we go. Let's see if we can make it. Always, always, always stand back and say to yourself, can I group this? And the answer is no. You got an 11 second there. There's no way this is going to group. So that means you still have to factor and sketch it. So that means you're going to start guessing numbers. You are going to guess possible rational roots, which are factors of this number. It's a 6 again, so it's going to be 6, 3, 2, and 1, over factors of this number, which is again just a 1, so you don't need to worry about it. Now, Moses is back there, and he said it's going to be -3. I have no idea what it is, but I trust Moses. So my first guess, I'm going to try -3. Now, if Moses would have said it's going to be -5, I would say, no, it's not, Moses, because the number I need has to come from this list. Is -3 in this list? Yeah, so I'll try it. Here we go. Everybody okay with the setup for the synthetic division? And you recall this number comes straight down. Now we multiply and add. We multiply Moses. I trust you, kid.
That's what I saw too. Once I got to 38, I was
Okay, so guess what? It's not -3.
Well, I think she's.
Oh, both of you said 2. Both of you said 2. So let's try 2. This is sort of like proving in geometry. Some of you are going to get it right away, and some of you are going to have to guess several numbers. So here we go.
Is there like a way to like get closer to your guys if it's no? It's too truly.
There it is. 2 works, which means don't lose sight. You're graphing, so that means you're going to put a dot at 2. Now what's left? What's this?
1x squared minus 4x.
This is the key, kids, to finishing the problem. Recognize as soon as you get your 0 that what you have left is a little quadratic. Jennifer? And a little quadratic, you should just factor. So how does that factor? X minus 3x minus 1, which tells me that my other 2 dots are at 1 and 3. 1 and 3?
Yeah.
They're all right here in a row. it's x cubed. Start down and up. There you go. Pretty impressive.
Didn't you also work it backwards? Like, so figure out what you need to do to 11 to get 6, and then just work backwards.
I suppose you could, but I think that's way to take some correctly. But yeah, if that's how you want to do it. Erica?
Can there be like more than one answer? Because I use one, like instead of two.
No, one works. So yes, any of these three numbers, 1 or 2 or 3, would have given you a 0. So you're going to guess one of those. And then your quadratic will factor into x minus 2, x minus 3.
Yeah, that's what I have.
Yeah.
And then, so for the answer you put in the little square thing, is that like?
That's the dot.
You put that, you don't flip it, you don't do the opposite.
No, it's the dot you plot. In the factor, it will be the opposite. But when the number that you put in the box is the number that you put on the number line. All right? Okay, tomorrow, we're going to have a little graphing quiz. But it won't be this. You won't have to do all this. I will have it factored for you already. So it'll be more like yesterday's problems that we did in class, where some of the factors will have squares on them. Some of them will have negatives in front of them. And remember, what does a negative in front do? Flips you upside down. So let's review real quick our general rules. If you are an even power,
You go straight.
no, I'm talking about an even power, x to the 4th, x to the 6th. You start up and end up. Unless there's a negative in front of you, and then you're down and down. If you are an odd power, you start down and end up. So if you're x to the 5th, if there's 5 x's, or 7 x's, or 3 x's, start down and end up, unless there's a negative in front, and then it's start up and then down. If your factor at x minus 3 and it's squared, that means the curve bounces off at that point, right? If it's x minus 3 cubed, it squiggles its way through. Remember all that from yesterday? That's what your quiz is tomorrow. The problem will already be factored.
What's the even one doing?
The even,
Like,
x to the 4th, start up and that was nice.